Do you guys see the space that we have here? So what I need to do is I need to determine the top and the bottom. Which one's the top? The second one. So we have the integral negative x squared plus 20. And we are going to subtract. The bottom one is x squared minus 4x plus 4 dx. What I need to do is I need to determine my bounds. How will I determine the bounds? Set them equal to each other. So as we go, x squared minus 4x plus 4 equals negative x squared plus 20. How are you going to solve this? And I get 2x squared minus 4x minus 16 is equal to 0. Now what? Factor out 2, I get x squared minus 2x minus 8. Factor that, and I get, yep. And so therefore, I have bounds of 4 and negative 2. So as D. Weiland said the other day, he said, this stuff went pretty well. Yep, these are kind of the gimme problems. I want everybody, if you get a problem like this on the test, got to get this one right. Notice as you draw the rectangles, they are vertical rectangles. Does it have horizontal width or vertical width? Horizontal width, so the width is dx. So you can see that's why we use the dx. As I combine terms here, we have the integral negative 2 to 4. Negative x squared minus x squared is negative 2x squared. I have a positive 4x, and then I have 20 minus 4 is positive 16. And I have my dx. Yep. If you draw your rectangle, do you see how the rectangle has a top where the red is, and the bottom is where the blue is? And if you look at the width of that rectangle, is the width horizontal or is the width vertical? The width is horizontal, so dx means horizontal width. Okay, what's the antiderivative of negative 2x squared? Plus 2x squared. And we are going to determine that at 4 and negative 2. Plug in 4. 4 cubed is 64 times negative 2 is negative 128 over 3. Plus 2 squared, or 4 squared is 16 times 2 is 32. You want to do the thirds? Okay, we'll do that. So D. Weiland says we're going to do 96 over 3 plus 4 times 16 is 64. All right. Times 3 is 192 over 3. And we need to subtract. Now I plug in negative 2. Negative 2 to the third times negative 2. So 16 over 3. Plus 8, or 24 thirds. Minus 96 thirds. So you gather up your numbers here. We got negative 128. You got plus 96. You got plus 192. Oh, that's a good point. Thank you, sir. We'll go back to You guys can use your calculator, but Riley called me out, so I'm going to go back to this guy right here. So this was 32 right here, right? So it looks like I get 32 minus negative 32. That's a positive 64, and a 64 that's going to be 128 plus 8 is going to be 136. Oh, I got to subtract 8, excuse me. So 120. Then I got negative 128 thirds minus 16 over 3, so it's going to be what? Negative 144 over 3. Is 144 divisible by 3? Yeah, it is. 72 would be half, right? So I think we're looking at 144 divided by 3 is going to be 48. So we got 120 minus 48. Well, 128 minus 50 is going to be 70, so we got 72. That's what I got. Is that what you got? Riley called me out. Riley is a very respectable mathematician, and I want to earn his respect. Did I earn your respect? Not yet. Okay, thank you. All right, flip it over. Let's try a different one. What makes number 3 different? Yeah, you got x is y squared. What does x equals y squared look like? Sideways parabola that opens up this way. Good. What about y equals x minus 2? It's a basic line. So the question you have to ask is, are you going to draw vertical rectangles or are you going to draw horizontal rectangles? Why are we going to draw horizontal ones? Okay. Yeah, it's important to recognize that right now if you draw a vertical rectangle, I'm okay. But if I draw the vertical rectangle here, then I have the same top and the same bottom, and they would cancel each other out. So that makes vertical rectangles not work. So what we're going to do is instead we're going to draw horizontal rectangles. And anytime you draw a horizontal rectangle, you can see that you're going to end up with the right and the left as distinct functions the entire time. So does that rectangle, the blue one, does that have vertical width or horizontal width? Vertical width. So we would call that a width of dy, dy, or dyland. So because I'm choosing to use dy, that means everything must have a variable of y. So I have the integral, and I need the right minus the left. So what's the right? X minus 2, but it has to be in terms of y. Yeah, so y plus 2 is equal to x. So I have y plus 2 minus y squared dy. I have to figure out where to bound it. My boundaries are not going to be x values. They're going to be y values. Notice as you look at the graph, the x values would both be positive, correct? But the y values, one will be negative and one will be positive. Do you see the difference? So therefore, we want to make sure we respect that. So let's look at these. We've got y plus 2, and we're going to set that equal to y squared. Subtract them over. 0 equals y squared minus y minus 2. Does that factor? Isn't it nice when it factors? So factors to 2 and a negative 1. Does that look reasonable with our graph that it would intersect at y values of negative 1 and positive 2? Hopefully we've done a good job of setting that up. So we have negative 1 and positive 2. What is the antiderivative of y? Y squared over 2 plus 2y minus evaluated 2 and negative 1. I'm going to see a common denominator of 6 here. So I'm going to try to earn Riley's respect again. Try to redeem my honor. So I plug in 2. 2 squared, 4 divided by 2, 2. So, sure, 12 over 6. Actually, you know what? I don't like to do that till the end. So I'm just going to roll a 2 plus 4 minus 8/3. If I plug in negative 1, I get a half minus 2 plus 1/3. So I have 2 plus 4 is 6 minus negative 2. 8. So that's going to get rid of those. And then look at this. This works out kind of nice. Negative 8/3 minus 1/3. Negative 9/3 or negative 3. Minus a half. So I get 5 minus 1/2, which is 4.5 or 9/2. Riley's still shaking his head. All right, buddy. Sorry about that. All right, and then let's do one more together. Flip it over. And it says, consider the functions. This one, you do need to use your graphic calculator. Consider the functions y equals e to the x, and y equals 6 minus x squared. Draw the curves, find the x values of the intersection, write an integral, and find the area round to 3 decimal places. Okay? So, what does e to the x look like? Yeah, it goes through the point 0, 1, and it heads like this. What does the graph of 6 minus x squared look like? Upside down parabola. And so, we all good? Vertical rectangles or horizontal rectangles? Very good. Vertical rectangles. Horizontal widths. Very good. So as we write the integral, it would be the integral from something to something of the top minus the bottom. So 6 minus x squared minus e to the x. So what we need to do is find the bounds of integration, right? How are you going to do that? Okay, but I'm going to have to use a calculator, right? So if we turn on our calculator, and so the reason why I'm having you do this is, without a doubt, this is a problem you're going to be expected to do on the AP exam. We type in e to the x. E to the x, and we're going to do 6 minus x squared. And we're going to look for those points of intersection. I'm first going to zoom standard. And I'm going to find the intersection. How do I find the intersection, Katie? Number 5. And it asks for the first curve. So e to the x I could call the first curve. And it jumps the second curve, 6 minus x squared. And I don't need to guess. And I've got negative 2.43148. Negative 2 point what? Okay, now we're going to do this one over here. So I can calculate intersection number 5. And I need to move closer to that intersection spot. I press enter and enter. And enter, I guess. I get 1.39778. There we go. those are my bounds. So negative 2.43148 and 1.3977805. Now, some people, they kind of wonder why are we writing out so many of the decimal places. It says round to 3 decimal places, and a lot of mathematicians, they get super conscientious about this. They're like, well, if the final answer needs to be to 3 decimal places, then who knows how many digits I have to plug in to make sure it's that accurate. So they just start to write them all out. At least that's how it generally happens at the AP exam place. So, but I do want it accurate to 3 decimal places. But you could probably just write it out to 2, and you'll probably be fine. So anyway, let's check this out then. How do I do this? Antiderivative. And we're gonna use our calculator though. Yeah, good. So Chris is saying let's make a third function. We're gonna take off y sub 1 and y sub 2. And for our third function, then what are we going to type in? Is it y1 minus y2 or y2 minus y1? Yeah, so I go vars, y vars, y, whoop, nice job, Jens. Idiot. Number 2 minus vars y1. There we go. And so that creates our third function, which is this guy right here, y2 minus y1. I second calculate number 7. And for my bounds of integration, negative 2.43148 and 1.3977805. Whoa, what happened? Oh boy. $13.315. Very good. Second calculate. When we do second calculate, we press number 7. That does the antiderivative for us. Calculates the area. Okay. So I've shown you enough examples now for you guys to be able to work the rest of your way. I just want you to consider number 8. We have 3 different functions, don't we? And the problem is I can't remember what the answer key says for me to tell you to do. I can't remember if I tell you to do this region here or if I tell you to do this region here. So let's check the answer key and see which one I show you. The answer key shows the green area, so so I'll draw it in red. So you want this entire space right here. And so it's a little bit trickier than the others, but we want you to see if you can work through that on your own. So, but you have the rest of the time to work. So we did 3 problems for you. So tomorrow we move on to volume. So we did area. We need to move on to volume. On your mark, get set, go.